Parent graphs. So these parent graphs, I would highly encourage you to memorize them if you haven't already. These are the most basic graphs, and they will be referenced all the time. It's just good to know the general shape of these different graphs. So reference this page. You'll reference it in your homework as well. Next, graphing adjustments, aka transformations. There are a lot of transformations here, but I'm going to give you a little trick. Instead of memorizing all these different things, there's a little memory trick I use. If something is outside your parentheses or the parent graph or the main part of the function, then you are going to transform it up and down, and it's going to be same or intuitive. So, for example, if I have x squared plus 2, that is outside that parent graph, so it's going to move this parabola shape up and down, and it's going to be the same intuitive. So plus 2 is up, minus 2 is down. If it is inside the parentheses or inside your parent graph, it's going to go side to side, and it's going to be opposite or counterintuitive. So if I have x plus 2 inside that parent graph, inside the squared, now I'm moving my parabola side to side, and intuitive, you would think plus 2, I should move to the right. But if it's inside your parentheses, it's counterintuitive. So that plus 2 actually moves you to the left. That's why I think opposite. So if you can remember these two things, outside is up and down and the same, inside is side to side and opposite, you'll see that all of these graphing adjustments fit in those two rules. So if we look at these negatives, if I have a negative, let's start right here, outside the function, I am reflecting across the x-axis, which would be up and down. If I have a negative inside the function, I'm reflecting across the y-axis or side to side. If I am adding something outside the function, then I shift up and down, and it's up if it's positive, down if it's negative. So that's intuitive, the same. If I am shifting something, or I'm adding something inside, then I'm shifting left and right, side to side. And it's left if it's positive, counterintuitive, right if it's negative, counterintuitive. Same with multiplying. If I multiply something outside, then it's a vertical up and down stretch. And if it's a stretch if it's positive, squeeze, or stretch if it's greater than 1, squeeze if it's less than 1, which is kind of intuitive. Bigger than 1, stretch. Less than 1, squeeze. If it's inside, now we've got a horizontal side to side, and this one is counterintuitive. If it's greater than 1, you squeeze. If it's less than 1, you stretch. Now these last two are the only ones that are kind of funky, don't really fit those nice two little rules. So these are two that you'll just want to memorize outside of it. So if you have absolute values outside, you're going to reflect all points below the x-axis across the x-axis. So it's kind of that up and down thing. So if it's, you erase that bottom half, reflect it up. If it is inside the function, this one's different. You're going to completely erase everything left of the y-axis. So if it's left, erase it, it's all gone. Leave the right side of the y-axis alone. Don't touch it. Then you're going to reflect that right half onto the left half. So erase the left, take the right, reflect it. That's what you do for those ones. So, quick note down here, adjustments to functions always produce functions. Those are all those graphing adjustments, and the next segment, which is the last, I promise, we're going to actually do those different transformations on an example.